Alright, welcome. In this video, we're going to be talking about factoring. We've done a little bit of factoring so far in this class. We've seen what it's useful for. When we studied quadratics, we were able to factor some quadratics, and that made us really easily able to find the zeros. And that's kind of why we're interested in factoring in general, is to make use of the zero product property. But unfortunately, I haven't really gone back and talked to you about the basics of factoring, which is honestly pretty regrettable. But here we are today, and we're going to take care of that now. So, find the greatest common factor of these monomials. So it's like, what even is a factor? We can decompose something like 4x into factors because we know there are numbers that multiply to 4, right? That 4 is 2 times 2. So we can multiply that as 2 times 2 times x. And then over here with 10x squared, okay, we can write the 10 as a 5 times 2, and the x as an x squared as an x times x. Right, so if we were looking for common factors, okay, we have a 2 in both of these expressions and an x. So we could factor out, if we had something like 4x plus 10x squared, we could factor that by removing the 2x, saying this is going to be 2x multiplied by, and then we were left with a 2 and a 5x. So that would go there, 2 plus 5x. Okay. So I'll show you this again, okay, with the negative 18b to the 4, which negative 18 would be negative 1 times 6 times 3. No, 9 times 2 is going to be the better way to write this. And b to the 4th, I'll write that as b squared times b squared, because I can see where this is going. And then 27b squared, okay, that's 9 times 3 and b squared. So common to both of these things, I've got this b squared, one of them only though, and a 9. Okay. So if I had, kind of like highlighting the leftovers in gray, if I had negative 18b to the 4 plus 27b to the 2, I could factor that up by removing out the greatest common factor, 9b squared, being left with, oh no, I didn't even catch that 2 right there, being left with a negative 2b squared plus 3. Just like we did in the first one. Alright, so now here we got some examples. We're just going to factor out the greatest common factor. When it says GCF, it means greatest common factor. So we'll start by thinking, okay, what's the greatest common factor of both terms? A lot of these are pretty easy, but I'll probably do a couple of them and then let you try the other ones on your own. So 6x minus 9. Okay, I'm going to say 6x is 3 times 2 times x, and 9 is 3 times 3. So I've got a 3 that's common, right? So I'll factor that out. Whoops. Factor that out there. 3. And I'll be left with a 2x and a minus 3. Guess I needed to have a negative 3 times 3 there. Okay. And then for 4x minus 16, I've got a 4 that's common to both of those. So I'll take out the 4 and I'll be left with an x minus 4. We've done this before. Okay. So now you try these other 4 on your own. Okay, you should pause the video because I'm just going to bring in the answers here in like 5 seconds. Alright, there you are. So, we factored out the greatest common factor after we determined what it was, and then, that was pretty much it for these. So it's one step, factor out the greatest common factor, see what you're left with, and move on. But these next 3 down below, okay, these are kind of going to give you an idea of where we're headed with this stuff. Okay, yeah. These all have a greatest common factor as well, but I might actually just kind of focus in on these real quick. Okay, so I'm going to say, okay, I'm going to show you that this one has a greatest common factor of x to all 3 terms, and then I'm left with x squared minus x minus 2. Okay. With this one over here, I've got, again, a greatest common factor of x times x squared minus 10x plus 25. And then over here, if I factor out an x, I'm left with an x squared minus 9. Okay, and All three of these expressions that I've highlighted in yellow are expressions that we've already factored in this course. These are quadratics that we know how to factor. So we can take it a step farther and we can say, all right, x times, okay, what are two numbers that multiply to -2 and add to -1? Okay, that would be -2 and +1. Okay, so we can factor further, right? We can say, okay, what are two numbers that multiply to 25 and add to -10? -5 and -5. Okay, and then we could even go a step further and say, okay, x minus 5 times, or x minus 5 is 2 powers of x minus 5, and that's x minus 5 squared. And then I guess I need a little bit more room to do this one. Okay, x squared minus 9, that's a difference of two squares. And we know how to factor that one as well. We know that x squared is the square of x, and 9 is the square of 3. So it's going to be x plus 3 times x minus 3. Okay, we've seen all these before. And this is really like kind of a preview of where we're headed with this, which is more factoring steps, because we're interested now in higher degree polynomials in Algebra 2. We're interested in like degree 3, degree 4, degree 5, things like that. All right, now speaking of difference of two squares, you might be like, wait a second, why can you decompose a squared minus b squared into a plus b times a minus b? And I think I showed you this, when we were studying quadratics, but just in case I didn't, this is really something that I need to tell you about. So we're going to use the distributive property to multiply the binomials. So x plus 6 times x minus 6. We're going to multiply it, we'll get x squared. X times -6 is -6x. Positive 6x and -36. And then we add those together, and -6x plus 6x, they add to 0, and so I'm just left with x squared minus 36. Maybe I can make that look a little better. Okay, and then over here, if I'm to distribute these, and maybe you try this one on your own. Yeah, pause it real quick and make sure you're doing your distributive property right. Okay, there it is. You probably did it right. People in my class are really doing well with distributive property this year. So, but again, the middle terms are going to add to 0. So I'd be left with x to the 4 minus 25. And notice that, this x to the 4 is the square of x squared. And the 25, okay, I can't use a gray highlighter on a gray pen. That's the square of 5. Okay. So what happens in the middle terms? They add to 0, is what I would say. And that's what we're seeing with the difference of two squares pattern, is that you've got x squared, you've got a number squared, and no middle term. So we know that middle term has a coefficient of 0. All right, so let's just work a couple of examples before we move on to other types of factoring that we have never seen before. So x to the 4 minus 16. This might be like the difference between, difference of two squares in Algebra 2 and what you had done maybe in a previous algebra class, is that, we'll be interested in fourth power situations. Well, x to the fourth is the square of x squared. So I'm going to say that this is x squared squared minus 4 squared. So I can decompose this into x squared plus 4 times x squared minus 4. Okay. And then x squared minus 4 is itself a difference of two squares. X plus 2 multiplied by x minus 2. And then I'll know I'm fully done, right? Because I don't have anything else that I can factor. Okay, so why don't you try x to the 5 minus x on your own? Okay, I might give you the hint that we're going to start by factoring out a greatest common factor of x, right? X to the 5 and x, those don't really look like squares. But if I factor out that greatest common factor, then I'm going to have a difference of two squares that will play out kind of like this one on the left, where we have like, a bit of an extra step. So why don't you try this one on your own with the video pause, and then you can check your work against mine, because it's going to come up in just a couple seconds. All right, there it is. So I factored x to the 4 minus 1 into x squared plus 1 times x squared minus 1. And x squared minus 1 can keep going because it's a difference of two squares. There's nothing I can do with x squared plus 1 because we don't have anything for a sum of two squares. You'll see more about objects like x squared plus 1 later in kind of the next semester when we study complex numbers. And just to wrap up the discussion of difference of two squares, I realize I never really wrote the rule down. But because what we're seeing here is that if we're multiplying, a plus b times a minus b, we end up with a squared minus b squared. This was kind of my point here. So we can apply this equality in reverse and say, hey, if we're looking at a difference of two squares, a squared minus b squared, we can factor that into a plus b times a minus b. And that's the thing that we just need to know for this class. All right, now let's factor by grouping. Let's do group and factor. So to get you ready, now we've kind of seen this a little bit when we factored things, quadratics where the leading coefficient wasn't 1. We used a grouping and factoring type technique that's going to look very similar to this. But we're going to mainly be focused on degree 3 situations. And so, but before I do that, sometimes I need to show you how a binomial can be a common factor, right? So really the addition or subtraction that I've got going on in this first expression is right there, that subtraction. I've got this object that's multiplied together, 7 times x minus 3, minus this other object. Okay. And I've got an x minus 3 in both of them, so I can factor out that x minus 3. And I'll be left with, well, what do I have left? A 7 and a minus 2x. And so I can, that's what we mean, that's what it's going to look like when we do factor by grouping, 7 minus 2x. Okay. And then, even what I'll say about this one on the right here is that this one here, it's got two variables going on, and I generally try to avoid those in my Algebra 2 class because I'm thinking about getting you ready for AP Calculus, which is, a one variable calculus class, and we don't really need to worry about x's and y's moving around together too often. But I think that this is right at your level, so why don't you try to factor these three expressions by grouping, or factor out the binomial. So pause the video, check your answer against mine. It's popping up in a couple seconds. All right, there you go. I think the only thing that, I might need to point out to you is when you factor out something like this, and, it's like, what do I multiply x minus 4 by to get negative x plus 4, or x plus 4 by to get negative x plus 4? You're just going to factor it out, and you're going to be left with a negative 1. And then over here, kind of the same thing, you were left with a positive 1 right there. So just don't think that you're not left with anything, right? Because if you were to go and distribute it back, you wouldn't get the same thing. Whereas with this, if you go and distribute the t squared plus 4 over that positive 1 in the bottom right, you'll get that last kind of copy of t squared plus 4. All right, here are 4 pretty solid examples of group and factor polynomials. So you're going to see it, and there's going to be 4 terms. That's kind of a necessity. And also there's going to kind of be like a parallelism. There's going to be this like constant ratio. From here to there, I went from 1 to 5. And that's going to be the same as going from negative 4 to negative 20. So that's going to be one of those hints that you need to do group and factor. Okay. Also, I don't think we have any other techniques that deal with a polynomial that has 4 terms. So if you see the 4 terms and the parallelism, you're grouping and factoring. So I say to myself, okay, what's common to these first 2 terms, the x to the 3 and the 5x to the 2? I think, there's no common number, so I'm just going to factor out 2 copies of x. I've got at least 2 x's in each of those expressions. And what am I left with? An x and a plus 5. Okay. And then I look at the second 2 and say, what's common to these 2? Well, I think just the factor of 4 and the fact that they're negative. So I'll factor out a negative 4. I'll be left with x plus 5. Then I'm going to factor this binomial, right? Because just like before in the ones above, I'm seeing a common factor of a binomial. So I factor out x plus 5. And I'm left with x squared and minus 4. Okay, so just to show you where I'm getting this from, use some color. And then x squared minus 4, that's a difference of 2 squares, so I know how to take that a little bit farther. I'm going to say that's x plus 5 multiplied by x squared minus 2 squared is going to be x plus 2 times x minus 2. Okay, and that's pretty typical. I think it's pretty common to, when you, at least in my class, the examples I like to choose, when you do group and factoring, one of the factors you end up with is a difference of 2 squares, and you can take it a little bit farther. And this is a way that we can take a third degree polynomial and factor it entirely. You just have to have carefully chosen examples. Let me do this one more time for you. I think I'm going to do the one right below and let you do the two on the right on your own. Yeah, I see the one in the bottom right is actually a second degree, but that's how we factored second degree polynomials when the leading coefficient wasn't 1. I think this one actually probably could have been factored by just factoring out the 2 originally, but that's a different discussion. We'll factor that one by grouping, just I guess because it says factor by grouping. Okay, with this one, 3x to the 3 and 5x to the 2, the only thing common to those is 2 powers of x. So x squared times 3x plus 5. Yes, and then this is kind of also a common thing to happen. Okay, I've got something that looks kind of like 3x plus 5, but it's not quite there. So what I need to do is factor out the negative. And so really what I'm doing is factoring out a negative 1, and then what do I multiply negative 1 by to get negative 3x? Well, that would just be positive 3x, and what do I multiply negative 1 by to get negative 5? Well, positive 5. And then I can factor out this 3x plus 5. And I'll be left with an x squared and a minus 1. And hey, that's a difference of 2 squares. Okay, and so I can factor that a little bit more and say I've got 3x plus 5 multiplied by x plus 1 and x minus 1. Okay, now I think you should try the 2 on the right. So I will once again pause the video, check your answer against mine, because here it comes. All right, there they are. So the one in the top right, okay, once you did group and factor, the thing that had the x squared in it, it wasn't a difference of 2 squares. It was a sum of 2 numbers, so there's no way I'm going to be able to factor that anymore. But the second one, it had something a little different going on. Kind of right over here, when I ended up factoring, okay, you need to know that 18 times 5 is 90. That was maybe a bit of a stretch. But this thing here, I saw both of these are even numbers, so I know that I can factor it more. It's not entirely factored until I've factored everything I can. So that's why I factored out a 2, and I was left with x minus 9 there. Okay? But that's group and factor. Alright, now let's talk about something that's totally new to you, and that would be sum and difference of 2 cubes. Okay, so I think what I'm going to do is I'm going to show you the formula, I'm going to show you why it works, and then I'm going to work an example. Okay, so I'm going to start off by, and I'm also going to give you a memory trick to help you remember the formula, right? That's also going to be important. So I'm going to start off by just telling you how we factor a sum of 2 cubes. Alright, so a to the 3 plus b to the 3 can be factored into a plus b multiplied by a squared minus b plus b squared. So I'm going to actually just multiply it out and show you why this works. Alright, so if I was to multiply it all out, using the box technique, notice the a squared b and the other a squared b, they're going to add away to 0. And the same with the ab squared, they're just going to be gone. And so I'll be left with an a to the 3 plus b to the 3. So, for example, I'm asked to factor x to the 3 plus 8, I'm going to go over here and say, okay, x to the 3, well, that's the cube of x. This is the sum of 2 cubes. So plus 8, that's a cube number, that's the cube of 2. Okay, so it's 2 to the 3. So I'm going to say that this factors into a plus b, so in this case, a is x and b is 2. So x plus 2 multiplied by a squared, that would be x squared, minus a times b, so minus x times 2, that would be 2x, plus b squared is positive 4. And that's how we factor a sum of 2 cubes. Okay, I'm just going to tell you right now, I think I'll prove this for you a different time, maybe when we study actual polynomial functions, but this thing right here, this second factor, when you do sum and when you do difference of cubes, it will never itself be factorable. It kind of looks sometimes like you should be able to factor it, but that you can't, okay? Because the a squared minus ab plus b squared pattern. If you're interested, I'd let you just, do the quadratic formula on that thing I highlighted in gray, and you'll see why it's not factorable. All right, now let's talk about difference of 2 cubes. Now this is another formula that we just have to know in this class. But I'm going to give you a memory trick to help you remember it. So I think, once again, I'm going to show you why this formula works. With a to the 3 minus b to the 3, it's going to be very similar to the other formula, right? And you can see there's just like some pretty pretty obvious differences, but overall it's the same. Okay, so it's going to be a minus b multiplied by a squared plus ab plus b squared. So, maybe you believe me after I showed you with the multiplication on the last one, but I'm going to show you again. Let's see why this works. All right, there it is. So when I do the multiplication and I multiply everything out, I see I have plus a squared b minus a squared b plus ab squared minus ab squared, and all I'm left with is a to the 3 minus b to the 3. Okay. So if I was going to do an example, I think the example on your book, let me just check and make sure real quick. Yeah, it's x to the 3rd minus 27. Okay, so my job here is to say, what is this the cube of? X cubed is the cube of x, and 27 is the cube of 3. Okay, so in this situation, a is x and b is 3. Okay, so this thing factors into a minus b, so x minus 3, multiplied by a squared, that's x squared, plus a times b, so plus 3 times x, plus b squared would be plus 3 squared is 9. Okay. And once again, just to remind you, this thing right here will never itself be further factorable. Okay. And that's sum and difference of 2 cubes. Oh, almost forgot to give you the memory trick. Let me get myself some more space here. All right, so here's the pattern. So, whether it's a sum or a difference of cubes, the inputs are always the same. It's a and b, whatever is getting cubed. And then in the second factor, it's a squared, a times b, and b squared. Right? This is the same way every time. And then what you need to remember is SOAP. Okay, that's going to be our mnemonic. So when I go in and I do, let's say, a sum of 2 cubes, okay, well, we're going to put in a sign here and there and there. Okay, this will be the same. Okay, plus and plus, those are the same. The second one will be the opposite sign, and then the third one is always positive. Okay, so same, opposite, always positive. Okay. And then for a difference of 2 cubes, okay, we'll do same, opposite, always positive. And so that'll be the trick you hear me using pretty frequently when you see me working this type of problem. And since we're still pretty new to this, I think I'm going to work both of these examples for you. So first one, this one, it doesn't look like a difference of 2 cubes or a sum of 2 cubes, but I do see that it's got a greatest common factor of 3x. So I'm going to kind of factor out that 3x, and I'll be left with an x to the 3 minus 1. And that is itself a difference of 2 cubes. Okay, so, when you're new to it, you should copy down the skeleton every time. So I know I have a difference of 2 cubes, so it's a to the 3 minus b to the 3. And it always starts off with a and b. Then the second factor is a squared, ab, and b squared. And then the signs are the same, opposite, always positive. Okay, that's going to be the best way for you to learn it and remember it, is just write it down a bunch of times. So for me, I'm going to have 3x times x minus 1 multiplied by x squared, positive 1 times x, so positive x, plus 1 squared is just going to be 1. Okay. And that's as far as I can go. Okay, with this one on the right, let's see what's going on here. Okay, I'm going to have to do group and factor, right? I'm seeing the parallelism, and also it's got 4 terms, so that's pretty much all I've got for something like that. Factor out x to the 3, it'll be x minus 5, and then there's nothing really to factor out of an x minus 5, so I'll factor out that plus 1 so that I can factor out the binomial and have something coherent to be left with. So I'm going to say over here, x minus 5 is what I'm factoring out, and I'm left with x to the 3 plus 1. Okay, x to the 3 plus 1 is a sum of 2 cubes. So I'm going to again copy in the pattern. I know it starts with a and b, and then there's a squared, ab, and b squared. Okay, it's same, opposite, always positive. Okay, so I'll have x minus 5 times, okay, a is going to be x and b is going to be 1, because 1 to the 3 is 1. So a is x, plus 1 multiplied by a squared would be x squared, minus ab is minus x, plus b squared is plus 1. Okay, and that's a couple of examples of sum and difference of two cubes. Alright, now before I let you go, there's one other type of factoring problem that you probably didn't see in Algebra 1 that I do want to give you in Algebra 2. And this one's kind of nice, because it can use other types of factoring kind of within this problem. So if you see that fourth power, second power, no power pattern, it's going to work like this. We're going to basically factor it with kind of like Algebra 1, but with instead of x plus a number, x plus another number, it's going to be x squared. Okay? So what I always say in class is I show them this polynomial. It's like, do you know how to factor this? And maybe one person sees it, or maybe they don't. And I say, you might not know how to factor this, but if I made a substitution, like t equals x squared, okay, then you might notice, or you might agree with me that not t to the 4, t to the 2 is going to equal x to the 4. We've been studying our exponent properties this unit, so you know that. Okay, so I could make a substitution and say that this original polynomial is equal to t squared plus 8t plus 7. And I always ask the people in my class, like, is this something that you think you could factor? And everyone's like, yeah, I could factor this. I could think of two numbers that multiply to 7 and add to 8, and so that would be t plus 7 times t plus 1. Okay? But, this was originally a polynomial that was an x, so I shouldn't probably be factoring it and getting t's. So I go over here and I would replace t with x squared, because that's what x squared represents. And so that would be x squared plus 7 times x squared plus 1. And now there's not anything I can do with this one, but you could see maybe if you had like x squared minus a number, how you might need to go a little bit further. So why don't you try the one on the right? Okay, that one has the greatest common factor of 6. You're going to start off by factoring 6, but then it will work otherwise exactly like the other one. So why don't you try this on your own, because with the video pause, because I'm just going to bring in the answer here in about 5 seconds. All right, there it is. So this one, after you factored out the 6, it worked mostly the same way. Once you made the substitution in for t, it was like, okay, we're just looking for two numbers that multiply to -2 and add to +1. We're pretty fluent in that operation. And then we go and factor, we resubstitute. But the difference with this one, that I was like, oh, okay, this thing right here, that's a difference of 2 squares, so I can do a little bit more on it, right? I can factor it up into these two things. And that is all the different types of factoring and all the examples that I wanted to work for you in this video. Thanks for watching. You need to just get to practicing your factoring now.